Assalamu alaikum, dear students. We are discussing the inverse of a function, that is invertible functions. Now today we are going to discuss the questions from exercise 1.3. Now the first one is, we have a function f from 1 2 3 4 to 10. Now this function is given in the tabular form as, that is it contains the ordered pairs 110, 210, 310 and 410. Now clearly this f is not 1 1, because different elements have same images, like 1 is mapped with 10, 2 mapped with 10, so this means that 1 and 2 different elements but their images are same, so it is not 1 1. Now for onto here, the codomain set contains only one element and it is the image element, that is a range of this f equals to codomain, so by definition f is onto function. Now f is not 1 1 but f is onto, which implies that f is not bijective. When f is not bijective, its inverse does not exist, so f is not invertible function. Now the second one is, we have a function h from 2 3 4 5 to 9 7 11 and 13. Now defined by in tabular form as 2 7 3 9 4 11 and 5 13. Now here different elements have different images, so when different elements have different images, it is 1 1. Here 7 9 11 13, here 7 9 11 and 13 are in the range, or in the range of h, so a range equals to codomain, that is the second set, hence function is 1 1 onto. When function is 1 1 onto means function is bijective, so it is invertible, its inverse exists. Now the second question is, we have to prove, or we have to show that f from R to R, that is from real to real, defined by f of x equals to polynomial 4x plus 3 is invertible. We have to find its inverse. Now how to find it is invertible? We simply show that it is a bijective, that is it is 1 1 onto. For 1 1, if we consider 2 points or arbitrary points x1, we don't know whether they are equal or not, x1 x2, such that their images are same, f of x1 equals to f of x2, but f of x is defined by 4x plus 3, that is 4x1 plus 3 equals to 4x2 plus 3. Now 3 3 cancels, 4 4 cancels, x1 equals to x2 for each and every point, hence f of x1 equals to f of x2 implies that x1 equals to x2, so the function is 1 1. Now for onto, now onto means each and every point from codomain is the is in image set or in the range set. Now let y belongs to R means codomain, second R, and suppose f is onto. When f is onto, this means that there should exist x belongs to first R such that f of x equals to y. F of x equals to, this means function is onto, and we assume this. So f of x is here defined by 4x plus 3, which is y, which implies that here we know y but we don't know what is the behavior of x. So in order to check the behavior of x, we need x from this, we need to separate this x from this equation, that is x equals to y minus 3 upon 4. Now this y minus 3 upon 4, y is real, y minus 3 is real, real upon real is real, so this means that x is real. Hence for each and every y belongs to R, there exists x. Now this x is of the form of y minus 3 upon 4 such that f of y minus 3 upon 4 is y. So our supposition is true, hence f is onto. When f is onto, this means that f is 1 1 onto, implies f is invertible function. Invertible function. Now we have to find such f, or such f inverse. Now while proving that f is onto, for each and every y belongs to our second or codomain, there exists x which is of the form of y minus 3 upon 4 in or means in first or domain set, such that f of x equals to y, that is f of y minus 3 upon y equals to g. Now this y is in codomain and this x is in domain. Now inverse function, when it exists, means that this y from the codomain is mapped with this x in the domain, So if we consider a function of the form of g of y equals to y minus 3 upon 4, g minus y upon 4, from r to r, here this r is actually the second, that is codomain. It is here the domain of the invertible function. Here y is variable, x is variable, so we can replace this x y by, for simplicity we can replace this y with x, so it is g of x equals to x minus 3 upon 4. Now we have to check that this is the inverse of f of x equals to 4x plus 3. Now we firstly find their composition, that is f of g of x equals to f of g of x. Now g of x is defined by x minus 3 upon 4. Now f of x is defined by 4x plus 3. Now replacing x by x minus 3 upon 4, it is 4 into x minus 3 upon 4 plus 3. Now 4 cancels, plus 3 minus 3 cancels, we get x. So this means that this f of g is actually from this or to this, or it is identity function, because x is mapped with x is arbitrary, so it is the identity function. Similarly you can prove that g of f, it is g of f of x. F of x is 4x plus 3, it is g of 4x plus 3. Now g of x is x minus 4 upon this x minus y upon 4, that is this. Now this cancels, 4 cancels, we get x. So again it is identity function. Now when it is identity function, its inverse is this x minus 3 upon 4. So whenever f of x is 4x plus 3, then its inverse is f inverse of x equals to x minus 3 upon 4. Here this is the domain of f, codomain of f. X is mapped with this y through 4x plus 3. Y is related with this x through x minus 3 upon 4. So x minus 3 upon 4, this is the the inverse for such function, means here g of x is f inverse of x. So thank you.